Mechanisms show the steps for how we believe a reaction takes place at a molecular level. When writing mechanisms, we draw curly arrows to show the movement of a pair of electrons. For example, when a bond breaks by heterolytic fission, we show the shared pair of electrons moving from the bond to one of the atoms to form a negatively charged ion. When bonds break by homolytic fission, the shared pair of bonding electrons are split equally, resulting in two species with a single unpaired electron, which we call radicals. When we want to show a single electron moving, we use an arrow with only half an arrowhead, which looks like a fishhook. In A-level chemistry exams, you do not need to use single-headed arrows. However, we will use single-headed arrows here to help with our understanding of this particular mechanism. The overall equation for the radical substitution of an alkane to form a halogenoalkane is as follows. We will now go through the mechanism to show the individual steps for how we believe this reaction takes place. The first stage is the initiation stage and involves the halogen, in this case chlorine, undergoing homolytic fission due to the presence of ultraviolet light to form two chlorine radicals. Radicals are very reactive. The next stage is the propagation stage, which are two repeated steps that build up the chain reaction. This is the stage where the two products are formed as well as further radicals. The first propagation step involves the reaction of the alkane, in this case methane, with the chlorine radical. One of the products, hydrogen chloride, is formed along with an alkyl radical. The next step involves the alkyl radical formed in the previous step reacting with chlorine to produce the other product, in this case chloromethane, and a further chlorine radical. The final stage is the termination stage, which, as the name suggests, brings the chain reaction to a close. This is when two radicals come together to form a molecule. From the chlorine and alkyl radicals we have made so far, there are three possibilities. Two chlorine radicals can pair up to form a chlorine molecule. A chlorine radical and an alkyl radical can form a halogenoalkane. Two alkyl radicals can come together and form a longer chain alkane. In this case, ethane is produced. Radical reactions are difficult to control and will inevitably produce a plethora of products, as well as the desired product.